The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, everyone, depending on what part of the country or continent or part of the world you are in. Very much appreciate everyone joining today on our panel discussion, which is going to be 3 data-driven approaches to mitigate corrosion threats. For those of you that attended our previous webinars, we are very happy and pleased to have you join again. About 3 to 4 weeks ago, we had a crossings focused webinar. And before that, we had a webinar that was focused around different areas for service providers where David Willoughby joined. And I could go on and on and on, different webinars related to API inspection, corrosion integrity, you name it. But today's going to be all about corrosion, ladies and gentlemen, and the approaches to mitigate corrosion via data-driven decisions. So with that being said, everyone, my name is Joseph Ladner. I'm going to be your moderator today. And what we are going to be going through is 3 different topics over data-driven approaches to mitigate corrosion threats. And we're joined today by our lead subject matter expert in the area of corrosion, Joe Pikas, who I'll introduce a little bit further here shortly. Before I go on in today's agenda, everyone, I want to make sure everyone's aware of kind of what this consists of. So this is going to be a pseudo live webinar. And what I mean by that is we highly encourage everyone to submit questions to the question chat bar there in the GoToWebinar interface. We will hold answering all questions to the end, but we have a dedicated session of roughly about 15 to 20 minutes at the end to answer any and all questions, or at least questions that we can get through from the audience. So as you have questions come through, please submit them as they come through, and we will answer them at the end. All right, so with that being said, here's our agenda for today. So first and foremost, we're going to talk about managing data silos related to corrosion. And with each and every topic, ladies and gentlemen, we're going to talk about what are the challenges faced in these different areas within the industry. And then also, of course, we're going to talk about software a little bit, right? Challenges within today's industry, and that's going to be led by Joe Pikas. And then also married to that, how Technical Toolboxes Pipeline Hub and the Corrosion Suite, because we're talking about corrosion today, right? Help solve these particular challenges via case studies from organizations just like yours. After topic 1, we're going to go through that same manner, but we're going to be talking about simulation models for corrosion. And then last but not least, we're going to be talking about determining remaining strength and metal loss of pipe. And we got a pretty cool picture to show through you here today that Mr. Pikas is going to go through when we get to that. Followed up with that, we're just going to do some introductory or just informational stuff about technical toolboxes, software related or training related, what the Pipeline Hub can offer for your organization, and then we'll finally get on to next steps. And that's when we get into the more or less the lightning Q&A round. We'll be answering questions as they come in. As with our previous webinars, we've already got some upfront questions that clients have participants have kindly sent us beforehand. So we have those already ready and queued up. But as questions come, please send them. We'll get to them towards the end of the day. So with that being said, let's do an introduction to our SME panel. So just starting off with myself, you're all here to listen to Joe Pikas today, but let me go first. I'm going to be serving as the moderator. I am an engineer by background, and I am our Director of Engineering Performance Advisors here at Technical Toolboxes. Some of you I may have talked to before, many of you it may be the first time. Great to have you join us all today. Background, as I mentioned, engineer by background, started in the field as a field engineer way back when, moved into business operations and consulting, previous at Halliburton Energy Service and the Alliant Group, and been at Technical Toolboxes ever since. Joined with me today is Joe Pikas. Now, I'm sure many of you have either heard of or know of Joe Pikas, but just in case you have not, Joe has over 50 years of experience within the pipeline industry, Most of that being with an operative Williams Transco with a specialization in the integrity and corrosion fields. From there, Joe has had various roles with service providers in the industry with a specialization in crossings, encroachment, AC interference, risk mitigation, and serving as a subject matter expert. In 2009, Joe received his NACE Distinguished Service Award, one of many that he has accolades and has collected. And as a leading voice in the industry, along with all of this, Joe is an influential author and has had over 50 plus papers and articles in his name via trade magazines and conferences. All right, so with that being said, as I mentioned, today's discussion is going to be interactive, ladies and gentlemen. So we're going to also have two polls, with the first coming up here in about 30 seconds, scattered throughout today's webinar. The first one I'm going to introduce to everyone. We're going to give you 30 seconds to answer the poll, and then we're going to showcase the results. It is very important for participation to us, so please, by all means, if you can participate, it would be highly helpful. And then towards the end, we'll do another one. So let's go ahead and get to our first poll, all right? I'm going to launch it, and it's going to be, what do you use currently for engineering solutions throughout your company? So let's launch the poll. All right, it's distributing the poll. Give it a second. All right, so I see some votes coming in now. So again, what do you use engineering solutions for currently in your organization? The first is going to be corrosion calculations and/or analyses, managing pipeline inspections, maybe asset integrity management, using corrosion for, or you're using your engineering solutions for pipeline design, or something other than the above. So let's give it another 20 to 25 seconds to allow others to vote. Looks to be heavily leaning towards corrosion calculations and analyses, which makes sense. That is our webinar today, and/or integrity management, some inspection, some design, and then other of the above, okay? Give it another 10 seconds, ladies and gentlemen. We're going to close the poll and distribute the results. 5 seconds. All righty, 3, 2, and 1. Let's close. Let's share the results. All right. Looks like, as I mentioned, corrosion calculations and/or analyses combined with integrity management are the two where most of people are using your engineering solutions for, followed by pipeline design and managing pipe inspection. So awesome. Really appreciate everyone's participation. All right, so I should be back to sharing my screen here. If not, please submit a question, and by all means, we'll try to get that fixed. But let's move on to the first topic at hand, ladies and gentlemen, which is managing data silos related to corrosion. So what we're going to be doing here, as I mentioned, throughout each of these three topics, Mr. Pikas is going to go through in depth with a lot of knowledge and a lot of experience on the challenges the industry faces in his eyes and what he sees in many conferences and many interactions he's had in the industry. And then he's going to go through various solutions that offer to that. And I'm going to go through a case study or two. So with that being said, Joe, can I pitch it over to you to go through managing data silos related to corrosion, please?
Sure. Thank you very much, Joseph. One of the things that we run into, at least it used to be back in the old days, is spreadsheets. But even today, companies are still relying on spreadsheets. And what happens when we start relying on spreadsheets when we got a pipeline that's, let's just say a couple thousand miles, and it goes from from south to north or thereabouts. And we have many districts, divisions in areas, okay? And are they operating on the same sheet of music? We all seen that commercial where these kids are, even when the kids are playing in a band and they're on the same sheet of music, it could sound very terrible. Well, this is what happens sometimes, when we're not And these kids were on the same sheet of music. So you can imagine if we're not on the same sheet of music, what's going to happen? We operate differently. Believe it or not, even if the area district are side by side, everybody has their own way. And this is where we get into trouble a little bit. And so you may have your set of calculations on your spreadsheet, and et cetera, and the other one, so on and so forth. So everybody is kind of protective of their own calculations. And this is how we get in trouble sometimes, because that same piece of pipe hasn't changed from, let's just say, from Houston to the Northeast somewhere. It's the same metallurgy, same grade of pipe for the most part, except if it's a gas line, it has different grades and so on and so forth, wall thicknesses, etc. And so we're really dealing with this, basically the same materials, but yet we're looking at it from different sets of eyes. We're calculating it from different sheets of music, and this is part of the problem. And are we getting the same results? And you say, well, we meet once a year to talk about, the way we operate. Really? Is once a year enough? Do you know your fellow peer groups from area to area, district to district, or division to division well enough on a day-to-day basis that you could share? And what happens when we run into issues? How do we do a like-similar analysis? How can we share that? That you have a problem in this area, maybe down, a few hundred miles down the road, somebody may have the same thing in the same kind of conditions. And this is what it's about. Lack of data and case centralization, even in your own district, concerns. I'm going to use the 3 strikes and out approach. And this really happened in a business unit, one of the business units. Happened that they went out, did a dig, okay, and they come back with the data, and they looked at it, and something didn't add up, to the dig sheet that they were given, and they compared it to the pig run. So they decided, let's go back out again, because things weren't matching. I'll just leave it at that. So they go back out again, and they redig again. And this time they found out they were on the wrong joint of pipe. So that was number one. And they found out a few other things. And instead of doing a full-blown investigation, they're in a hurry again. They're in a hurry all the time. And instead of doing a full R-string calculation, with multiple increments, they just took 2 readings, the maximum depth and the maximum length. And obviously it failed. And they had some pictures, and the people in charge says, you know what? There's still something not right here. That shouldn't have failed, So back out a 3rd time. Okay. This time they gridded it and they did it right. Okay. And it turns out that the established MAOP of the pipeline was okay, when they did it, when they used the R-string calculation. Obviously, when you reuse the original calculation, ASME 31G, it failed. And that's why R-string came into being about 30 years ago, is because B31G fails on anything. You could sneeze at it and it literally fails. So these are the kind of things we learn real quickly. So they did strike out all 3 times, in my opinion. We don't need to be doing that. You could take that same dig and do it downtown New York City. May have only cost them maybe $10,000 at this location. I could tell you a minimum starts at $250,000 dig. So you better get it right the first time. And there's many reasons for it, because of the population density. You have to rent a cop or cops, to protect that area. And it just keeps on going from there. So if you get the picture. Solutions. So how do How do we get around this thing? Even in our own districts, integrated digital environment. Are we sharing that information? Are we collaborating with everyone in the system, including our own district or area? Can anybody view it? You don't need to raise your hand. Hey, I want to see that particular dig number 18 or something. We should be able to all look at it, have different set of eyes looking at this kind of stuff. And this is why it's important. Do you have the system for it to do that? Does everybody have right to get in and look at it? Because the more sets of eyes, the more you could do a better assessment. And having central data storage, not my storage, they're not going to get my spreadsheets. They're not going to get into my computer. Versus collaboration, for these calculations and sharing these case histories, so we could actually begin to build an integrity program. Because integrity program doesn't operate with one division or one district or one area. Joseph?
Thank you, Joe. Really do appreciate that. So let's go to example case study, ladies and gentlemen. So really kind of marrying and piggybacking off of what Joe said is, Technical Toolboxes, we work with 400 and to be exact, 435 different organizations around the world, most of those being here in North America, US, Canada, Mexico. But with that said, every organization has a similar problem, is whether if it's three people in a small consultant shop or a $100 billion Fortune 50 company, is you have different engineers doing different things in siloed work groups that might have their own solutions. And a real good example of this was this isn't just one particular operator, but for this example, there was an engineering team, or it was teams really, that worked across different business units, and even particularly in one business unit here within the United States. And it turned out each group, and then even each engineer, had a little bit different ways of doing things. I mean, of course, there was some standardization on upload your documents to SharePoint here, or utilize this exact calculation for this here. But it turned out that different groups, as the company acquired different organizations, just did different things, So the various engineering team analyses was limited by siloed data, lack of collaboration methodology. Okay, you got Bob Smith, the engineer here, Sally, the engineer here, different groups, both in the state of Ohio, and doing the same, having the same goal, but doing it a different way. What does this lead to? And maybe not in this particular situation, but on a macro level, when you're looking at it from the president or the vice president of engineering, it leads to elevated operational and capital expenditures, ultimately leading to higher risk. You have a lack of standardization and a lack or methodology of sharing information. It leads to increased cost. It leads to time equals money. It takes longer to do things, and then of course that equates to higher cost. So what was the solution in this scenario? If many of you attended the Crossing Solution webinar last week, we went into this in much more detail, but within the Pipeline Hub, Technical Toolboxes has various crossing suites that consist of API 1102 Willow Trackload, but are in a standardized solution with it, which is in the hub. So what does the hub allow you to do, ladies and gentlemen, for some of you that aren't on it or on it not that often? It is a centralized platform, right? Think of your smartphone. If you have an Android, you have an iPhone, or just a smartphone, that is a centralized database. You have your email, you have your phone, your text, you have your social media apps, or ESPN, whatever. And it's on a centralized platform that allows you to share data to make your life easier, right? And that is what the Pipeline Hub allowed this particular organization to do for analyzing crossings, and then also marrying that to their corrosion work. So here's the example. What the hub allowed them to do was they were able to integrate R string, remaining strength of externally corroded pipe, to get their go, no go for maximum operating pressures based on exact minimum wall thickness. Okay, so they do that first. They then are able to take those analyses, and again, it's all one platform, right? Integrated environment, and marry that to their crossings analyses for wheel load, track load on their encroachment management. So the corrosion group was able to share what they were doing for R string to the design engineers and to the engineers that were running crossings, get their minimum wall, and then run the go, no go analyses for their concentrated point load and then surface area, i.e. wheel load, track load, very effectively. Instead of having siloed solutions via spreadsheets that was hard to share information, instead of having just different solutions on different platforms, R string here, maybe pipeline toolbox or an internal use software here, having all of this centralized on one platform really helped solve this particular group in terms of standardization, lowering risk, and ultimately lowering the amount of time that was spent on doing these analyses, which means lowering operational expenditures. So this was a really good case study I'd like to share with you all, how you take different siloed solutions, leveraging your asset data all in one centralized environment, i.e. the hub, to reduce risk, lower total cost of operations, i.e. accelerate project schedules. Okay? So let's go to our next topic at hand, which is simulation, models and simulating. And you see here, you're probably going to understand via corrosion. What we're going to go to next is AC interference. We have no one better to talk about that in more detail, which is Mr. Joe Pikas. So Joe, can you go into simulation models and the challenges and solutions with them in today's industry?
Absolutely. And one of the things that we run into, and we're all experiencing it, and I've seen it like crazy, you know, is encroachment. And encroachment comes in many ways, not just more utilities, but people. And these are the things that we need to be thinking about. And then lo and behold, because of the constraints in the availability of right-of-way today, in landowner issues, AC power lines, pipelines, just systems with cables and anything that goes underground is going to go in, and that includes underground power lines too. Take your subdivisions. You know, most subdivisions don't have any wires strung out anymore. Everything's underground. You know, including your internet service and so on and so forth. So this is what we're dealing with, and the restrictions are even getting tighter all the time. And now they're putting in pipelines where they thought they would never put pipelines, you know, literally on top of each other. I've seen this in Corpus Christi, where they put 3 stacks, 3 levels of 8 pipelines across from each other, underneath each other, in 3 decks. This is what happens when the right-of-way gets tight, and they're all about a foot apart. Isn't that nice? So how do you protect? How do you prevent shielding? Now you combine it with AC power lines in the same right-of-way, along with other utilities. And now you've really got a threat. And then you have to model it. And so this is what we're talking about. And how do I model? You know, these are the things that we need to be looking at. How do we come up with the predictive prioritization, you know, to look at this, the analysis and prioritization that's required, and still meet the PHMSA requirements? You know, because one of the things that PHMSA has been asking pipeline operators is, okay, guys, we know you have all these power lines on your right-of-way, or vice versa, you're on their right-of-way. Tell us what the faults are going to be on at every tower. Did you answer that question? This has been asked by PHMSA to many pipeline operators. How are you going to run that? How do you know what's going to occur? What's the likelihood of something occurring, and what kind of damage can you expect? This is why we have models, AC modeling, for this purpose, to do that, to do every tower on that right of way. So even though you may not have a AC induced AC issue per se, there's no reason you can't have a fault, because when you get lightning strikes, when you get episodic upsets where power lines touch each other from wind and other disruptive storms, anything could happen. And these are the kind of things we need to be looking at. So these are our challenges. And how do we make the assessments for these? And we even got some new stuff. You know, we always worried about DC interference, you know, from rail systems, and of course from other pipeline systems. But how about solar systems? How about these miles or kilometers of solar systems that are laid out? And how are they grounded or not grounded? Or are they using the ground as a return, a negative return? Isn't that nice? You don't think that pipeline that's nearby is going to pick some of that stray up? I've worked with some clients on these type of systems. Yes, they are a threat. So as solar goes in and other systems go in, it's not just the rail systems anymore. We have to think outside the box more than you could imagine. You know, when you go and take data loggers and see that that whole area where that solar system is located is depressed, there's a reason for it, and that needs to be investigated. So these are the kind of things that we get involved in. So what I'm bringing up is what are the solutions? Well, the solutions are AC interference, modeling, and corrosion modeling. What is my current density on that pipeline? How bad is it? And is it going to cause the likelihood of AC corrosion? And then when you start combining it with DC effects, then you've got a real problem. You have to be ready for this type of analysis. And in some cases, you may have to use FEA models, but in most cases, you should be able to handle it with the conventional models that are out there. The key is data, getting the right information. This is one of the key factors, that we have to deal with. And then, to add insult to injury, right? We got the external issues to deal with, right? We got internal corrosion. Now, there was a time when, the gas supplies were from just a few key places in the United States, mainly from the Gulf Coast or certain areas of the country. And that was it. And then all of a sudden, Utica came and Marcellus and this one and that one, and all around the state of Texas, all around the country. And then all of these systems are now feeding into these major transmission lines. Okay, so we don't have the one source area anymore. Now we have all these lines, production systems feeding into these transmission lines anywhere along a line. And now we have to deal with, again, episodic upsets from the production. And all of a sudden we have additional water in the system. Where did that come from? You know, winds up in the, like in the gas line and the scrubbers and things of this nature. Shouldn't be any water in there. Never used to be. And all of a sudden, you know, we have fluids, corrosive fluids. And if they become, this is the problem. Once you start getting episodic upsets, now the system becomes wet. And now you got to treat it as a wet system anymore, not just episodic. It occurs once a year or twice a year. That's not good enough. And these are the kind of things that we have to come up with models to determine, yes, how much water is coming in, how much corrosive fluids, what type are they? You know, what kind of bacteria is now coming into the system? We got to start looking at more things than we ever thought about, including inhibition and biocides and things of this nature, cleaning pigs and more monitoring pigs. So all of a sudden, our solutions become very complex, both on the internal side as well as the external side. And Joseph, I'll hand it back over to you to work on the remaining part of it.
Thank you, Joe. Really do appreciate that. Kind of in conjunction with Joe was talking about with modeling and simulation, one area that I wanted to spend a little bit of time focusing on is, hey, you know, this is about corrosion, right? Technical Toolboxes Pipeline Hub has various suites within there, and one of those suites being corrosion, and one of the apps within that suite is our AC mitigation power tool. So my last example, ladies and gentlemen, was about a service provider, right? Sorry, not a service provider. I'm going to step ahead of myself, an operator. The one I want to give you now is about a service provider. And, you know, they were utilizing, you know, a homegrown solution, and another group was utilizing a different software platform, completely different, for AC interference issues, and doing their modeling for potential AC issues within an operator's pipeline that they were doing an investigation for. So, you know, they do this all day long, right? You get an event, you know, it's triggering an internal investigation, working pretty close with the operator to determine if the newly constructed pipe is going to require mitigation, some type of cathodic protection design, etc. So really the issue at hand was, you know, it says one engineer, but, you know, this was multiple engineers within a particular group that did things a different way, right? Hey, you know, no fault at all. I've done this, it's worked. I've done this, it works. Great, hey. But when you have a larger project and you need to work collaboratively, and each person is used to a different solution, you know, then it gets into, okay, maybe which one's better, etc. And that's not what we're about here today. It's all about standardizing, right? So what this particular company evaluated was, hey, okay, this solution works good as a standalone. Maybe this one does as well. But is there something out there that's better that comes with an integrated solution where we have integrated GIS, where you have integrated, you can integrate your data, you can leverage other aspects such as doing your cathodic protection design in the same system, sharing that to your other engineer in a different group across the state, and also both of you are running the same modeling program on a platform that at the same time is a full corrosion suite that has other capabilities too, such as R-string. That was what was evaluated here, and the ultimate solution was our AC mitigation program, which again is part of our corrosion suite. So the AC mitigation power tool has integrated ArcGIS interface via Esri, by the way, and allows engineers to, if you have AC interference issues for obviously steel lines running near and parallel to pipelines, no matter how long, if it's hundreds of miles or hundreds of kilometers, you can upload this within the GIS interface, save time, and run your AC modeling and mitigation very quickly and appropriately. Once that is done, it's all in the same interface, right? So if you are running your AC interference and you see you have these induced voltage current issues, and you got to modify your cathodic protection design here, do a little bit there, hey, you can go within Pipeline Toolbox in the same platform and alter your CP design there as well. So you can see the effectiveness, the productivity gains, it goes without being said because everything is integrated into one platform. You get the ease of use via the automation via GIS. You're leveraging your data tools and your asset data and having a single point solution that is now integrated into the hub that creates efficiencies for not only you as the engineer, but if you're a manager or vice president, for your entire team, because everything is standardized and you have multiple point solutions on one platform. Ultimately, what this allowed them to do is get the projects done much quicker, that they have now adopted full time on all projects going forward, that ultimately reduces risk and creates an optimal AC mitigation design for their clients. Okay. Hopefully that kind of made sense for everyone. And we're going to go to our last topic at hand today, which is determining remaining strength and metal loss of pipe. So I mentioned to you at the beginning, there was a little tidbit or secret about a picture we wanted to hone in on, that Joe honestly wanted to hone in on. And this would be the picture, ladies and gentlemen. So Joe, before going to the next slide, I'm going to have you take it away from here.
Okay, so this is an ugly picture. Okay, let's take a look at it before I take you into determining the remaining strength of corroded pipe. We got a welding issue, obviously. What do you think they did here? We got the pipe scratched up. So we got stress concentrators in there. It looks like they even cut into the pipe to fit it, so it comes together, and then they welded those cuts, and you got splatter all over the place, and it looks like this welder was just practicing for the first time. This is what they used to do when this is how welders learned how to weld, is they would weld casing pipe together. And I've seen better welds on casing pipe than I've seen here. And even the workmanship of the welder, they're supposed to have a nice fine way to, when they lay the bead. This doesn't, there is no workmanship here at all. It looks like this guy got the fattest rod he could find and just stuck it into the metal and splattered all over the place, and whatever came out came out. And obviously, if you went to do a corrosion investigation here with all these issues, and remember, girth welds are a big deal, and you could see the poor workmanship. You could see many defects of gaps and porosity, and oh my gosh, I can't. There's so many defects here. I can't even name them all. But but this is what happens when you let people that are not certified to work on pipelines. I don't think this was done in this country, but I just wanted to pass that on. That we would not be able to do something like that when it came to using our string or any other calculation. So what are we talking about? Now that we saw that, it's bad enough. We got the cost of pipe materials. Now we need to think about the repair materials, the labor to put them on, and something like that would have to be a cutout. I'm not saying you couldn't put a sleeve on that, but I wouldn't want to even attempt it because of all the issues that are with that particular piece of pipe. I mean, that would be a definite cutout in my opinion. So this is one of the things that we need to look at is not only just the cost of the pipe itself, but how can we repair it and bring it back to the established MAOP, or maybe even to the design. What if you're going to uprate the pipeline down the road? You need to think about that, because you may be operating at one pressure, but it's good for higher pressure. And somebody says, well, why don't we raise, oh, we lost something here. Why don't we raise the established MAOP? So we need to prioritize the sections for repair. And that's one of the big challenges. And we have different methods, either like a type B steel sleeve, becomes a pressure retaining vessel. So if you did have cracking, that would be a perfect application. You could use your composite sleeves as appropriate, but keep in mind, one of the things that the regulators say is for a permanent repair. So do all these repair methods meet that definition? So keep that in mind. And this is one of the approaches that we have to think about when we're coming to repairs. We're not just there to slap on a composite sleeve or just just clean the pipe with a wire brush and recoat it, if it doesn't need anything as a complete repair to hold pressure. But these are the kind of things we need to really think about. Is we want to do it right the first time, because even just to clean and recoat requires surface preparation. It requires the materials that need to be put on there properly and applied properly, and they're going to be a permanent repair. So we just can't blow that off. And then we need to think about the excessive repairs. Do we need to repair everything? Or because we deal with immediate, we deal with schedule, and then we have remaining, what's left, and they could be scheduled out accordingly. So keep that in mind, that we have a good process for making that determination, and then factoring in the effects of metal loss on operations. What happens if we do run into a situation where we don't have the materials ready? Immediate pressure reduction. So these are the kind of things that we need to keep thinking about. They should be a part of the process. Or when you're involved in digs, you should have pressure tested pipe in case it's required to do a cutout. All this should be done in preparation before you even start, so you don't have some of the problems that you need to think about. And where does that go back to? Well, that goes back to having a system that you could come up and determine to see what's going on. You could predict. You have the ability, because once you have the data in there, then now you have the predictive capabilities of thinking about what you can be doing for the next go around, for the next ILI run. You could be planning all this, and you could be budgeting, and this is where all this comes together. So the solutions are, simulating. We should be able to simulate these and optimize these repairs. Determining the reassessment interval. If we have a certain corrosion rate, okay, and we're not slowing it down, whether it's internal or external or both, they could be two different ones, and we're not controlling that, then we're losing, our grip on it, because to keep the costs down, do we need to, whether it's internal or external, do we have enough cleaning pigs? Do we have enough inhibitor biocides? Is this no longer an episodic line? Is it now a truly wet line, based on the water that we're pushing out? These are the things that you need to keep ahead of the game, and then able to pinpoint the corrosion to minimize investigative digs. Have we established that process where we could do this? We could establish that on our GIS systems. And this is one of the things on our mapping systems and in our centralized database systems. So that's why it's important to centralize these cases. And And when we're doing a big picture, we could look at it from the standpoint, are we doing like similar analysis? Do we have the same situation at point D as we do on point E or point M? You know, do we need to start looking at it that way? So we could do that like similar analysis and know where to focus our attention. And then of course, then comes the inspection, inline inspection. Remember that inline inspection is after the fact. What we want to do is start reducing those effects. You know, we don't want to be having a dog chasing his tail each time. And so this is one of the things that we need to think about is we got to stop that, break that cycle, and then we could start going from there. Joseph?
Joe, really do appreciate it. So with roughly 15 minutes left, we'll kind of truck through the rest of this and make sure we have enough time for the Q&A. So similarly as the other two, everyone, where the simple case study here is kind of back to an example with an operator. An engineering team, for this one actually pertains to a really large Fortune 500 company, operator to be exact, with assets all over. Needed a solution to repair critical corroded sections. This is external corrosion, by the way, of pipe in a right-of-way that identified long length corrosion areas that needed repair to operate it safely. So, and again, when you think about this, you know, this particular group had different solutions. There's different ways to do this, right? It's no secret. But when you have, or when you operate a lot of mileage of pipe, when you have a lot of work coming in, you know, to do this quickly and to do this effectively, it can be tough, and also do it accurately, right? You know, there's ASME B31G, there's modified B31G that are level 1 analyses. Our string is a level 2 analysis, which means it's much more accurate. It's taking a different, or using a different calculation via a 3-phase folius factor instead of ASME B31G modified. So what's the solution for this group? Is, again, back to the corrosion suite. This particular group looked at taking R-string plus, which is an advanced version of R-string that actually saves a lot of time for organizations. Why? Because R-string itself, again, a much more advanced, accurate calculation, but it's just looking at and taking one analysis of where, if you simulated a wall thickness or pristine pipe here, what is needed to be done per calculation, no matter how long the corroded area is, to safely operate that pipe at your maximum operating pressure. What R-string plus do is it automates that. So let's say you enter your desired MAOP for this particular pipe based on grade, SMICE, OD, whatever, you know, P design, etc. And it's going to automate, based upon the pit depths and corrosion you've uploaded, automate the number of sections you need to simulate a wall repair. Now, what that repair is, a coating, sleeve, whatever it may be, simulating pristine pipe in that area so you can safely operate your pipe at that desired MAOP. So what does this do? No matter how long your corrosion length is, this provides the engineers a tool to run their analysis effectively and reliably in a very quick manner. So if you have miles of corroded pipe, not even miles, if you have just meters, or if you have yards or feet of corroded pipe, this allows you to, in a quick manner, simulate what areas need to be corrected, what areas need to be fixed, instead of digging up, in this instance, you know, yards, if not miles of pipe. It allows your engineers to quickly simulate the exact area and via automation. So that is the R-string plus solution that is married in the Pipeline Hub. And what is all this done by? This is all done via the Pipeline Hub, which is an integrated platform and digital transformation within the oil and gas industry. So the Pipeline Hub allows you to leverage your asset data that marries together different applications, and I'll go into those applications here in a second, across the pipeline lifecycle. Pipeline Toolbox is included in this. You have the Corrosion Suite, which we talked about today. And then we also have different suites as well: Crossing Suite, Integrity Suite, Inspection Suite, etc. This allows for standardization, transfer of knowledge, and allows your organization to scale as it grows very quickly and effectively via everything I just mentioned, plus all of the SME support, onboarding, and adoption that is provided by Technical Toolboxes. Sorry, I'm getting a little feedback here. So what applications are centered around the hub? Many of you probably know of Pipeline Toolbox. You probably have also heard of RString as well. But within the hub, again, it's an integrated environment, right? We have different suites that cover the entire pipeline lifecycle, from crossings, integrity, corrosion, welding, hydraulics, and inspections. Today, our focus was around corrosion. Corrosion consists of RString, some ECDA components, AC mitigation, and various aspects of Pipeline Toolbox, and fluid simulation models as well. But you can see it's not just within corrosion that is centered within the pipeline hub. You have integrity suites, crossing suites, others as well that I just mentioned. But again, to briefly recap today's corrosion webinar, really do appreciate Joe Pikas kind of going through that. Within the Corrosion Suite itself, it offers, of course, Pipeline Toolbox and the corrosion modules within that, cathodic protection, corrosion, etc. RString Plus for that level 2 analysis, some external corrosion direct assessment components, and of course the AC mitigation power tool. Now with that, what I also wanted to make sure you all aware of, as I went through, of course, the software aspects of the hub, but please make sure that Technical Toolboxes has a whole nother arm of our organization, which is our training arm. Some of you have probably attended that. Some of you may not have ever heard about it, but you know, of course, Technical Toolboxes offers and licenses software that's all centered in our pipeline hub. But within our training, we have different training courses centered around RString and defect assessment. We have a course coming up at the beginning of October on that. External corrosion direct assessment, another coming up in mid-October, October 11th. We have cathodic protection and buried pipe training webinar coming up, and again, late October. And then different trainings coming up with microbiology influence on corrosion, pipeline AC interference, and corrosion management for aging pipelines. Each of those have different SMEs. Some of them you'll be blessed to hear from Joe Pikas again, if it's, say, an RString or defect assessment training. But there's others as well that's led by David Willoughby and other industry experts. Please feel free to visit our website if you wanted to learn more about those trainings, where you can receive professional development hours, certifications, etc. So with that said, let's go to the Q&A. I have some emails drawn up, Joe, that I wanted to go ahead and start asking you, sir. So the first one, Joe, is kind of very quickly, Joe, what are the benefits you see in Technical Toolbox's AC mitigation program versus others? Because the follow-up question to that is it's like, hey, we know there's SCS, we know there's the ULSICA. What does the AC mitigation program offer in the hub that maybe the other programs do not, if there are any?
Well, that's a great question. And one of the things that the AC mitigation power tool offers is the ease of use, in the sense that it's designed for pipeline engineers, and you don't have to be a power person or a double E. And that makes a big difference in the assessment of the likelihood of AC corrosion, the assessment of faults and things of this nature. And I would say because of that ease of use, it doesn't make it simpler. It just makes it in a way that pipeline engineers understand, versus being a power person designing substations. That's the difference. It's meant for people designing pipelines, not substations.
Appreciate that, Joe. Another question for you, Joe. Can my peers see the RString cases that I created? Looks like this user utilizes RString. Can my peers see the RString cases that I created in my district And can I view their district cases so we can analyze the entire line together?
Absolutely. This is the purpose. This is actually the purpose for what we've been talking about today. Is that everybody has a stake in these digs. Everybody has a stake in the integrity of the pipeline. It's not just limited to a pipeline group. That's the design. That includes design engineers, everyone working, because it's about integrity. It's about the maintaining the safety of the pipeline. So everybody should have a stake and understand what's going on, and because when we look at things with a different eye or set of eyes, it's amazing. Oh yeah, I saw that before, and yeah, I recognize that particular type of an anomaly or indication, and this is important for everyone to understand. So when you're doing a root cause analysis, this is what the bottom line is. Why are we experiencing these type of problems and this type of corrosion? And it's important that everyone understand that and see it.
Appreciate that, Joe. A little bit of a slightly off the wall question, but I believe it's good for the topic at hand today from a technical standpoint. Looks like an operator or maybe a service provider, I'm not sure, as they're dealing with solar farms and they're having DC interferences as well as AC. How can that be? That's the question, Joe.
Yeah, well, I think I covered some of it, but let me give you the remaining part of it. That was a great question. One of the things, like anything else, there's DC power lines too, and they're out west, and they transmit a lot of energy, and then they convert it back to AC. And sometimes when they go into a fault mode, they'll discharge to ground. Okay, and hopefully they don't design them that they use the ground as the negative. And unfortunately, we don't have controls over solar farms. Okay, we're hoping that they have a negative return on everything, and that it's properly set up so it doesn't leak current to the earth. But the problem is we don't know, what's going on, because there's no rules or regulations on solar farms. They build their own things, and I know in South America we had an experience where the potentials on the pipeline were totally depressed in that area, and of course then they picked up on each side, which kind of tells me that they're experiencing some issues there, whatever it may be, whether it's affecting ground or is it a true interference. And this is where studies come in, to make those assessments. Am I seeing just a ground depression, or is it truly interference? And this is where experience comes in to make those determinations.
Awesome, Joe. Appreciate your insight into that. Looks like someone wants to expand a little bit more on kind of my case study about the zero out method and R-string plus, Joe. The question is, can you tell me how to simulate corrosion effects, long length corrosion, to optimize repairs using the zero out method? Could you expand on that, Joe?
Sure, be glad to. The zero out method was set up for the purpose of doing many digs per year. And the whole purpose was there are many effective areas. Let's just take an example. It's 120 inches long of corrosion, okay? And when you go to run the calculations, you're gonna see many areas that look basically the same depth. And you're saying, well, why is my program only showing that one? And I got 120 inches of length of corrosion, from a few mils up to whatever, 100. 150 or 200 mils deep. And so one of the things it does, which is it shows all the effective areas. Okay. This is the only program that shows all the effective areas that impact the established MAOP. And what the zero out method does, it zero outs only those areas of concern that need to be repaired. Now we're not saying you don't have you could still repair the 120 inches if you want. That's up to you. But what we're saying is, why not? It's up to you, depending on the type of method of sleeves that you're using. Why not just repair the areas that the R-string program points out? And so the zero out method shows those areas of concern. And then if you repair them, they'll bring your pipe back up to the established MAOP that it was designed to do, or the design pressure if you want to go back up to original design. So we allow either or, established or P design, pressure design, and only make the repairs that have to be made. We're not saying, and this could save, particularly when you're using what I'll call the yellow jacket, that's very expensive, and they're only about 11 inches long. If you could just put a few of them on instead of 10 or 15 on the pipeline, you just saved yourself probably a couple $100,000, depending on the diameter of the line, and that doesn't include the labor.
Joe, I appreciate that. We have a few questions that unfortunately are going to have to go unanswered. I want to be mindful of everyone's time. I see some people filing out, but there was a couple questions. Let me make sure I answer this very quickly. Will we have access to the recording? Yes, you will. We will take this webinar. We will upload it to our YouTube page. I don't have a time frame on that, but that will be coming. So when that is there, be on the lookout for our YouTube page when we upload that there. And Stuart Como will be reaching out to everyone, one of our colleagues here, where he can disseminate that information around and really to get your feedback on the webinar, or any unanswered questions that we can answer would be great. But again, thank you, everyone. Again, if your questions went unanswered, we will follow up with you directly on some of those to make sure we address that. I'm sorry that we ran out of time a little bit today, but thank you all for joining today's webinar. Hope you got at least something out of this, whatever that may be. But thank you all for attending. We're going to have more of these coming up again in September, and then in October, etc. For those of you that are in Canada, Technical Toolboxes will be attending and boothing at the IPC International Pipeline Conference in Calgary in late September. So for any of you that are attending that, please stop by our booth. We will most definitely be there. Be excited to see you and shake your hand, talk a little more there. But nonetheless, thank you, everyone. Have a great rest of your Tuesday, and enjoy the rest of your week. Bye.